Okay, hello everyone. I'm Pranav Kasela. I'm a PhD student from University of Milano-Bicocca. I'm currently in my last year of my PhD under the supervision of Professors Gabriela Pazzi and Raffaele Perego from ISTCNR. Today we are going to talk about the personalization in information retrieval and the biggest problems that we have, the challenges we need to focus on to solve this problem. The presentation will be divided in two main sections. One is regarding the data sets, which is a big issue in this field. And the second one is the models that we have developed to personalize, let's say, the results. But what is personalized information retrieval? It is somehow to tailor the results of a search engine according to the needs of a specific user. For example, if the user is interested in music, let's say, in specific kind of music, and he just writes a query regarding, let's say, music, a very generic query, we need to be able to somehow give the results that are more relevant to the user without the user requiring to add more information to or more context to the query. But the biggest issue we have in this field is the data sets. Collecting the data sets with user-related information has a lot of ethical implications. Indeed, one of the biggest data set that we have, or I would say the only one that we have, is on the web search engine is the AL query log from 2006. The problem of this data set was one of the user wrote information regarding himself to search himself on the web. So we could infer who the user was just from the collection of the queries and the documents. So we had no information regarding the user directly, other than the queries that he wrote, but we could infer who he was using this information. So there are a lot of ethical implication in the collection of this kind of data sets, and a lot of work needs to be done in that field. The one we developed are using academic search and academic data sets, which are publicly available, so we are not violating any kind of privacy to a certain degree. And the other one is using Stack Exchange, which is a commonly used forum, online forum, where users are able to write information, and they are actually providing the information themselves, all the information that they need. The first one is the academic search engine. It is based on a methodology developed by Tabrizi and who's an Iranian scientist, in which way what they do is assume. So they have some very strong assumption actually. The first one is that they assume the query of the user to be the paper or the scientific article that they wrote, and the relevant documents are the documents that are cited by this specific paper. This data set that they developed and this framework for personalized information retrieval had a lot of issues. One of those was that it was not numerous, so there was not enough documents in that one. So we extended this methodology, and we are able to provide around 18 million documents for the collection and 1.9 million queries. And this is, if you take into account 4 different domains. The dataset is based on Microsoft Academic Graph, which is an openly available dataset. The basic structure of the dataset, it has the document, which is the scientific article, and we have the title of the article, and also the text, which is usually the abstract, but in some cases you can also have the full text. We do not take in consideration the full text because it is somehow noisy, and not all the documents have this property. Then we have the keywords that are user written. So the user wrote those keywords and chose those as something described in the document, the publication date, and the timestamp. Then we have some information regarding the author, so the affiliation, so which affiliation did they have. The query is the title of the article that they are writing. And we have also some information regarding the user, so which is the conference and the journal it was published in, and also the field of study, which is a big piece of information that we have. It is computed by using machine learning. The point is the documents cite themselves, so you can find a self look there, and we consider all the possible relevant document for a given query, which is the title of the paper, the documents that are be cited. We put another restriction on the relevancy of the document. So given a query, we take also in consideration the abstract. So since we are only using the title in the abstract, the biggest issue is in a paper, there are some cited pieces which are not available in the abstract, and you cannot infer from the abstract itself. So it should be in the top K for us, top 1,000 results of BM25. So there should be a lexical matching there. By using this methodology on the 4 domains, as we described, there were around 18 million of documents, which are equally divided among the domains. We have many users, actually, more than the document itself, because usually a document can have multiple users. And we can assume in this case, in this simulation, the first user of the paper to be the author of the query itself. This was the first data set. And in the second one, we shift our focus to a different subtask of information retrieval, which is expert finding. But what is it? And we use Stack Exchange as the main website. The main benefit of using Stack Exchange is that it has multiple communities. So we have a good variance of data. Many people have used actually Stack Overflow for developing some data sets. But the problem is it's completely focused on computer science. So the model that they're able to develop is not robust, and it does not generalize to other domains usually. So we wanted to use multiple domains. Indeed, in this case, we combine around 50 domains that are available. In Stack Exchange, there are around 176 domains. We use 50 of those, which can be somehow considered under this huge umbrella of humanistic domains. So this is done because if you use scientific domains, they usually have specific language which can affect a little bit that is, for example, in mathematics field, you have formulas which are quite hard to parse in specific cases, but the new large language model are able even to tackle this one. And the biggest thing is we have the option of the user selecting the best possible answer, which is not always the most upvoted ones. Since it's a community-based forum, what we have is the user who is asking the question can select the best answer, but there are also other users that can interact with the questions and the answer. Indeed, they can upvote the question and the other answers. This is a big piece of information because the most upvoted answers are usually very high quality. But the best one is the most relevant for the user who wrote the answer, who wrote the question itself. And we have also some other information, for example, the number of views that the question had received, or the date that the question was asked, and also some information regarding the reputation of the user. We also have the biography. Eventually, the biography is not always available, and the number of awards, the number of actions that the user has already done on the website. But what is actually expert finding? In most cases, we are unable to search for an answer, a perfect answer for the question of the user. It's true that the new large language models are somehow able to generate an answer for the specific user, but if we are able to find an expert in this subtask, what we want to do is we want to find an expert, a candidate user with very specific properties, with a very, very good knowledge of the specific domain that the question is being asked in. And we simply provide the expert with the question so he can answer it manually. So it's a human written answer. What are these properties that we want? First of all, we want that the expert has a very high engagement level, so he's really active on the website. In this case, we ask for this property by considering that the user has given at least 5 best answers in a specific community. And the other one is that he has a very high acceptance score, which is the number of best answers that he has given upon the number of all the possible answers that he has given. So this is how many times he get the best answer award, let's say. And we want him to be higher than the median acceptance scores of the community. Given the first condition, we also avoid cases where there's a user who just starts his account, he writes an answer, he gets the best possible answer, so he would have an acceptance score of 1, which is the highest possible. And in this way, we are able to find around 3,300 experts with 255,000 questions, which we split in training, validation, and testing, using a temporal split to avoid any kind of data leakage. So the training questions are all the, and the testing questions are the questions that are written after a specific date that we have specifically decided. In this case, it was 2019, if I'm not wrong. And there are 564,000 answers from these 3,306 experts, and we have 81,000 users. So now we'll describe two models that we have developed. First model for using the first data set and the AL query log, and the second one using this second data set. So the first one is the denoising attention. The question we asked ourselves is, but the personalization is really useful, or does the one size fits all works in the case of a search engine? Well, sometimes it does work. So if the user is asking a very factual query, let's assume the date of let's say, birth of a specific historical person, we do not need to personalize this kind of query. There's no use. It would just require more resources, and it's not going to add any value to our results. And is the personalized results useful? Well, it's a very problematic area in this case. For example, in web search engine, there's a big issue regarding privacy. So if you are somehow able to personalize the results, there is somehow a negative impact on the search engine itself, because the user is thinking that he's being tracked somehow. And it's very difficult to explain to user what's happening and what's not happening behind the hood. We cannot assume all the users to know how the models work and the underlying model works. And where are we getting the data from, which is another issue. Let's assume to have the user data for now. The main question is, how do we represent the user interests, and how do we leverage them? There are many possibilities. In our laboratory, we explored two of them. One is the personalized re-ranking. So we use a first stage retriever, which is very recall oriented. So we try to retrieve all the possible relevant documents, and then we re-rank them using personalized scores. And the second one is a query expansion. So we try to expand the query using query expansion terms, but we try to somehow personalize the language model according to the user data that we have. For the denoising attention, the first intuition that we had is not all the user related information in a user model is equally related to her current search. Let's assume you have interest in both music, math, and data science, and you want to write a query regarding the music. Your interest in data science and mathematics is not as relevant to your specific query. So you want to discard all of those information. Most of the works, actually, what they do is rely on all the possible information without doing any kind of pre-filtering in the academic literature. So our objective was to leverage long-term user information, so not a session-based, because in a session, usually a user is writing only information which is relevant to the specific query. So in this case, the problem does not arise. But if you have a long-term user-related information, you need to identify which are the most useful one for the current search. So the solution that we propose is weight the user-related information using the attention mechanism. At least this was the initial proposal that we had in our mind. But this does not really work very well if you think about it, because the attention mechanism underhood, they use the softmax function, which is a generalization of argmax function in a continuous way somehow. So what they do is generally skew the weight to a specific document or specific set of documents. So while the others are given always a positive weight, never a negative one, Okay. So they're never given a negative profit, and the sum of the weights is always 1. So this in personalization indicates that we are always personalizing, because the whole sum of the weights given to all the user documents is 1. So there is some kind of personalization going on. So translating, let's say, the attention to the user modeling, you want to compute a context vector by weighting the contextual information with respect to a given input. The context vector is the user model in our case. The contextual information is the user-related source information sources, and the input is the query. Somehow the slide got shifted some in this version of PowerPoint. This is the architecture that we rely on. This is the B encoder general in this case. And so what we have is the top results given by a first stage re-ranker, a first stage retrieval, which is recall oriented. We rely on BM25 actually. Then we take a language model. In our case, it was a variant of a BERT, fine-tuned on our data sets. So we have 2 data sets that we'll show later on. So we fine-tune 2 different variants of BERT. And then we compute the representation of all the top results that has been retrieved by BM25. Then we have the user historical documents, and we embed them using the same language model. We share the same language model between the module A and module B. And then there is an optional part, which is not optional for our proposal, but it's optional in general, in which we compute also the representation of the query. And the main magic is happening in the user representation module, in which we understood the softmax function is not working really well. So the classical attention formulation is not working. And then there's a possibility of summing all this to 1. So we wanted to adjust these 2 problems that we had. So what we propose is somehow shift from a softmax distribution to a uniform distribution. So each document has the same weight regardless of the similarity that was computed, or better, the distribution of the similarity that was computed. And then we want to filter out all the noisy documents, which is a parameter that is learned in this framework. So it's not a parameter that we control, but it can be fixed also. So we did an experiment also by fixing the parameter and not training it, and try to see in an ablation study what kind of impact that it had. Then the user representation is computed by matching the user document representations and the query representation and giving a weight to them, and then computing a weighted sum of the relevant documents according to the query. And then we simply use a scoring function to compute the similarity between the top results retrieved by BM25 and the user representation to achieve a personalized relevance score. In this case, the scoring function was a cosine similarity with a shift to it to be between 0 and 1. For the baseline in this experiment, we compared BM25 as the only non-personalized baseline. Then we had, for the personalized one, we have the attention mechanism, the classical formulation of attention with the softmax function. Then we have a zero attention, which is one of the few works that focuses on non-personalizing a query when there is no need to personalize somehow. Which in their work, they are able to achieve better results than the classical formulation, but in literature, we have seen that it's not always reliable, because what it relies on a specific vector, which is able to, let's say, eat all the non-relevant information. Then we also we also test with the multi-head attention, and by averaging all the representation of the user as they are. The data set is the AOL query log, so web search data set, and the academic search data set we presented in the first part of this presentation. So what we are able to see is by denoising and by using a uniform distribution rather than a softmax distribution, given that we had some intuition on the sum and the assumptions on the theoretical working of denoising one, it is able to outperform both the non-personalized baseline and all the personalized baselines by a very big margin. Let's take the NDCG in the web search data set. We are able to almost achieve 10% in an absolute increase in NDCG, in terms of NDCG, and almost 5% from the best performing personalized baseline using attention mechanism. Same goes for the academic one. In the academic search, we are also able to outperform all the possible both personalized and non-personalized baselines. And the last model that I'm presenting now that we are working on, by the way, the first two works are all like the first one, the academic search dataset, has been published in CKM of last year, so 2022, while the expert finding paper has been accepted in the CGIAR AP this year, and it will be presented in November, while denoising attention is still under review. But the preprints of all of them are already online if somebody is interested in them. So the last one is the expert finding. So we rely on the Stack Exchange dataset we presented in the first part. And in this case, the problem is, of course, representing the documents and the queries is somehow, I think most of us are familiar here. But how do we represent an expert? So we do not have a textual representation of an expert directly. There are multiple ways to represent an expert. So for example, we can take the collection of all the possible answers that or the questions that they have answered to, or the other social structure. So there are some works going on that are working on some social structure and trying to detect the collaboration between the experts, because what they have seen generally is when the experts collaborate, they achieve better performance, because in Stack Exchange, you can also give a comment to an answer, and the answer can be edited later on. And the other question is, given a representation, how do you retrieve an ideal expert for a given question? So in this work, let's say we wanted to create some baselines for the data set that we have provided. So the idea was not try to develop the best possible model, rather to see if personalization is useful also for expert finding, because this is what we were focused on. So the research question was slightly different from providing, let's say, the state of the art. So to represent the expert, we choose to represent it using all the answer that an expert has given prior to a specific question that you are considering. So you have to, each time you have to avoid any kind of data leakage, you have to take only the answer that have been given before a specific question. So this represents all the knowledge that the expert had before the question was published. Then the problem is, if you use again all the possible answer, this contains a lot of noise. This can be tackled using the denoising version that we presented, but these two things were developed in parallel, so we did not use denoising, employed still denoising this one, but it's something we are doing currently. So we are working on applying denoising on this one as well. There are also a lot of features, as I mentioned. So the biography of the user, the upvotes he has received, the reputation he has, and the number of awards, the type of awards that they have received, that can be explored, and the social interaction that they had with the other users. This is a set of features that is available there and needs to be explored, in my opinion. For us, we use the text-based score. We use two possible scores in this case, which are text-based score and the personalized scores. So we rely on BM25 and the neural models, which are Distilbert and MiniLM, to give text-based scores on the relevance of the question and all the answers that the expert has given before. And a tag-based model in which we simply measure the number of overlap between the user historical tags. So the user who is asking the question can assign tags to the questions. And the expert has the tags of the questions that they have answered before. So we take all the historical possible tags and try to understand the overlap, which somehow gives us information regarding how many interests that the user asking the question and the expert giving the question have in common. Because if you have a specific question, for example, let's say you're interested in both music and mathematics, and you ask a question regarding Fourier analysis, which is the analysis of the waves, you might want some examples of music, something related to music as well. You would be like interested in those kind of answers. So if you have an expert who knows about music as well, it's usually better. So by using this, what you wanted to see if the tag one, which is the personalized score, is able to always improve over a given baseline, which is true for 3 experiments that we did. So we rely on BM25 scores, and we add the tag scores simply by using a weighted mean, which is optimized on the validation set. This is the last slide for me. So we do the same with mini-LM and with Distilbert. In all cases, we are able to statistically, which is a Bonferroni corrected statistical test. It's a t-test. We are able to improve over the baseline. So this indicates that personalization is useful in expert finding, and it needs to be explored further. And we hope to also apply denoising on this one and to improve the overall results. But for now, we are able to somehow say that personalization can be indeed useful for expert finding as well, which is a subtask of information retrieval not thoroughly explored also with the usage of large language models. It would be nice, for example, to use large language models and information regarding the expert to also generate a possible answer. And this is something that the community is going towards. I think Quora is starting to use large language models to give a possible answer, and they can rely on expert information, which they do not still do, to give a possible best answer. Thank you. This concludes.